Good morning, everyone. Welcome to another coding video, kind of. I already coded the thing that's specified, I assume, in the title, and I just wanted to show it off a little bit here. I was looking on Upwork for some work, and I came across some projects that I thought, hey, if I can build these things, I can just put it onto my Upwork resume or portfolio and show it off, and it actually shows off some pretty interesting and useful work, at least based off of the skills that I put for myself on Upwork. Hopefully, I can market it to the person once it's fully completed. It's not exactly how I want it to be, but let's just get right into it. So essentially, I made a maze generator and a maze solver. The basic premise of it is, let me run the code here. We have our maze generator here. We start from the left, and our goal is to get to the bottom right. As you can see, there's a little bit of bugs here. The maze generator cell is still showing up for some reason. And then when it gets to the end of the path, it looks like there's a space missing right before it gets to the end of the path. That node is actually there, but for some reason it's colored in black. I don't really know why. So those are some of the kinks I need to work out, but how the program works is we essentially set our tiling and our window resolution. Tiling will give us our columns and rows for everything. I can increase this if I want to. Oh wait, no, sorry. Increase it to decrease the amount of tiles, but then decrease it to increase the amount of tiles. Now my tick rate I think is set to, or frame rate, is set to 60. That's why it's going so quickly. So if I change the tile to 50, we have a much larger maze that takes a little bit of a while to generate, but it looks really good, in my opinion. And the way that I was looking into how to make this thing was actually really, really smart. The guy who made it was really, really smart. I'm not very good at coding, but I'm still trying to learn every day. The way this algorithm works is that it searches randomly. It essentially looks for, and the red spots here you can see is backtracking. Try and explain this a little bit better. We have the cell itself for the maze. It has its initialized definitions, XY value. We have a walls value, which is actually really useful and really cool when we're generating the maze. I'll get to that later. And we have two states, or I guess two variables for visitation. For the first one, it's meant for maze generation because I can't use the same variable again. I no, I can't use the same variable again because when you're traversing through all the paths, every cell is eventually going to be visited. There's no way for me to actually reset every single cell without going through all of them again. For some reason, that also seems to mess with the walls variable. I'm not really sure why. I think it's just a side effect from doing that. And so I created a visited variable for the maze generation and a solved variable when the maze is actually trying to solve itself. We have some draws here. Yes, I did separate it. Again, the same way I'm doing this. I understand it's probably not the most efficient thing, but I did it anyways because I was having so much problems trying to separate the states between generation and solving, which this actually helped me a lot to understand that because I've realized in video games and I guess animations and that kind of stuff, you need to obviously have different states, but I never understood how that worked until I tried to actually make it myself. It's just booleans, basically. That's how you change states. The hard part is actually also knowing what to reset and what to not reset. We have a way to check our cells when we're generating. Essentially, we have a anonymous function. So the way the maze works, we have an anonymous function. Our cells and our grid, when we're generating it right here, this grid is a one-dimensional array. So in a one-dimensional array, how do you find which row and columns to look for? Well, we have this algorithm right here, actually. X plus Y times the columns. For here, we can do some error checking on the boundaries. If we're at a bound, then we can just return false because it has nothing. And then here we'll return the index value of the current cell that we're in, or as you'll see, in the cells or the neighbors of the current cell that we're checking. So as you can see, let's say we have the top corner right here. You can't go top, you can't go left, you can't go down. So the variables here, top, left, and bottom, will be false. So we never actually check that. That means the only way for us to go is right, using our check cell generation function. If the cell neighbor exists and hasn't been visited, append to neighbors. So let's say you have multiple choices. You can go bottom, you can go right, you can go left. Essentially, if the current cell's neighbor exists and hasn't been visited, we append it to an array called neighbors. It's called a list, I understand, but whatever. Then we return choice neighbors. This essentially randomly chooses which neighbor we want to go through. And then if not, we backtrack if it's not the right path. We have remove walls here. This is actually pretty cool too. We check the walls beside the current cell and the next wall, then remove it. So let's say we have our current cell, it's square. Our next cell is a square, obviously, right? We do the difference between the walls that are directly beside each other. So we have our current wall here. Let's say we're checking on the right side of the current cell. We would also need to check on the left side of the next cell, do the difference, and then create a path. That one was really, really cool. I didn't realize how this was done, but this is actually really cool for generating the maze. This is how you actually create your paths and create your walls and stuff like that. We have list comprehension for creating the grid of cells. We set our current cell to the first cell in the grid. We have a stack for backtracking. We have a state. This is how I separated the generation of the maze from the solving of the maze. And then we start our game loop, I guess you could say. In the state of maze generation, we have another piece of list comprehension where we draw our cells. We track the current cell's visited variable as true, obviously, because when we're at the current cell, it means it's been visited. We draw that current cell to the screen, and then we use next cell, which will give us, by using the check neighbors function, it'll give us the next cell we do by randomness, assuming there's multiple choices. If there's not multiple choices, we'll have one. If that next cell actually does exist, we set that next cell's visited to true. We append the current cell to the stack, and we remove walls for the generation, for the maze generation, and then set the current cell equal to the next cell so it actually moves along a path. If there's no next cell, meaning the way to go top, bottom, left, and right none of that is possible due to whether it's boundaries or whether it's been visited already, we actually pop from the stack. That's how we backtrack, which is really, really cool. I always knew that's how you did it, but implementing it is really, really cool as well. Like, just implementing it and seeing it backtrack is just so interesting. And then after that, we have our frame rate. I can make it go higher depending on how quickly I need the maze to be generated, but I keep it at 60. If the current cell is equal to grid cells at 0, basically what that means is that if our current cell finally gets back to the original path that it took, so if we, let's say, generate this whole maze, I should have lowered the tiling before testing this, but it really is really cool. Once we get back to the first spot, then we start from the first spot to then solve the maze. Yeah, we get to the start, basically. We put it into the new state of solving. We set the current cell equal to grid cells. There's no reason to do this. I'm still trying to figure out that bug where the current cell doesn't seem to be correct. I'm not sure why. Yeah, and then we have a delay of 1 second. Just, I was hoping it would fix certain things with like the rendering and the refresh and updating the screen and whatever, but it doesn't seem to be working. I'm not sure why. I assume maybe it's just because I need to put this here, but again, I'm not really sure. I'll have to figure that out later. Now we move on to solving the maze. Everything is technically the same, actually, except for our solving condition, which is if the current cell is equal to the last cell. So for me, the way I generated the maze, it goes from the top left to the bottom right. That's what the path is supposed to be. And there should be a path going down to there. I could find a way to randomly generate the exit either at the top right or the bottom left or somewhere in the middle. I don't know how to do that yet. I haven't really worked that out on paper. But basically, if our current cell reaches the end of our one-dimensional grid cells, meaning it's the end, bottom left, or sorry, bottom right, Then we found the path, delay by 5 seconds, and then exit. I just did the delay just so I can see where the path is going, and then still working out on those bugs. And again, we have the exact same code. We're just using the other visited variable to do the pathfinding. Yeah, and we do our traversal. The colors here are just, you see the purple, so that's pretty much what that is. Yeah, and that's basically it. It's pretty much the exact same code, except some minor tweaks here and there to make sure that the states are working properly and that the generation and solver are sort of distinct so that I'm not getting strange side effects and errors. I hope you found that somewhat comprehensive or somewhat useful to you. If I've learned something from this, is that looking at Upwork to see what people want is actually really useful. I'm planning to do more of that kind of stuff. Maybe I'll make more videos on it too. So stick around. If you want to learn more about coding. I made this in Python. I don't know if I mentioned that, but it's pretty obvious that I did. Just to get back into it, I've been using JavaScript a lot. So getting back into Python, I was a little bit rusty, but it wasn't too bad. Yeah, with that being said, hope for good luck in all of your projects. I understand this is not the most difficult thing. This is something people in high school or university do, but I'm really just trying to get back into the swing of things in terms of logically creating a program and not just like front end work that I've just been it's been so boring to do front end work because I still don't really understand how it works. I'm still trying to understand front end, back end, full stack, whatever you want to call it, how these things all connect with each other. So, yeah, thank you all so much for watching. Subscribe if you want to see more, and like the video if you like it, dislike it if you dislike it, and I'll see you next time. Goodbye.